Yeah. Reflection. Simply to say, let's say I'm taking this as a surface. It is a surface. So these lines I'm showing you, the other side is not a surface good for the light strike. It's shaded. It's dark. It's dark. This is something like the mirror, where the light can be turning back. What's the word? Turning back, bouncing back. A light ray falling on a surface, a straight line, right? From this point, what happens is, giving the same angle, it moves out into the same medium. A light ray falling on a surface, turning back or bouncing back, moving into the same medium is called reflection. It's called reflection. So in this case, there are some parts that we have to learn. There are some sort of parts you have to learn here. What are the names of them? What are the types of the rays? And what are the angles being formed up? And what are the theories, relationship between them? So a diagram, a simple diagram, along with two laws for reflection, you have to learn. Okay, right. Let me take this diagram. Let's say this is the mirror. This is the mirror. And a light ray falling on the surface in this. So this is the point where it is falling. This is the point where it is falling. So I mark this as A, B. This point I named as B. Okay. For this point, imaginary we are drawing a diagram, a line. And this straight line is at 90-degree angle. You can see it's at 90-degree angle. It is an imaginary line. Otherwise, we can't see them. We can't touch them. It's imaginary. Okay. And from here, there will be a ray going out in the same medium. I'll name it as BC. Okay. And the mirror I'm naming as MN. That is not must to take all these letters, just examples. Okay. And this straight line is the perpendicular line. I'll mark it as BA. So the same letters I took it from your table. Okay. Now we have to name them. And you can see in between AB and BX. AB and BX, there is an angle. I'll name it as I. And there is another angle between BC and BX. BC and BX. I'll name it as R. Okay. These are the terms. I have to name them. MN. What is MN? MN is the mirror. Okay, it may be a plane mirror, it may be a curved mirror. Maybe a plane mirror or curved mirror, right? Basically, here it is a plane mirror. Right. And BX. BX is the normal. The perpendicular imaginary line. No. And B is the point of incidence. B is the point of incidence. Exactly where it is being incident. Let's say a light ray comes to my hand. It is falling at this point. This is the point where exactly it is being incident on. So this is called the point of incidence. So to the point of incidence only we are drawing the imaginary line. That is normal. And AB, that is the ray which is being incident, right? So we name it as incident ray. Incident ray. And BC, that is a ray going out, right? Reflecting out. So that is the reflected ray. And I is the I is the angle between the incident ray and the normal. Incident ray and the normal. So we name it as incident angle. That is the angle, incident angle. And R is the angle between the reflected ray and the normal. So R we name it as angle of reflection. Reflected angle. Reflected angle. Okay. I and R, there's a relationship. And we can give another word for them also, mathematical. How do you name I using the term? In maths, how do you name this angle? No, how do you name? I think that is a word they use in maths. Name. ABX angle. What is angle? ABX. So I, you can write it as ABX or else XBAB. This comes in questions. And R, you can mark it as CBX or else XB. Both of these. Okay. So these are the fundamental parts of plane mirror. Plane mirror. Upon the reflection, these are the terms you can find. And what are the relationships? There are two laws here. What are the two laws? The first law says that There are three lines here. Right? What are they? A, B, B, C, B, X. Incident ray, reflected ray, and the normal at the point of incidence. All three lie on the same plane. What is the first law? Says that all three are lying on the same plane like this. Something like that. All three are lying on the same plane. You can say all in one plane, right? Vertically one plane. Or else maybe horizontally one plane. It cannot be like this. It cannot be in this way. In a 3D way or 90-degree angle. So it cannot be. All three, whatever the plane you may take, but all should be on the same plane. You can say all three on the same plane. Just like our three fingers when we are stretching. When you are stretching all completely, all three would be on the same. Wherever, whatever the angle we are turning around would be on the same plane. Would be on the. So this is the first law. And the second law says that. Now I said the reflection angles are there. I mean incident and reflection. So I and R are equal. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. That is the second law. That is the second law. Is that clear? Okay. So first law says all three A, B, B, X, B, C, but you have to name them. What is A, B? Incident ray, reflected ray, and the normal at the point of incidence lie on the same plane. Incident angle is equal to reflected angle. That is I equals R. Clear about that? Is that clear? So this is the fundamental theory about reflection. Okay. Let's write down. Reflection is. Reflection is the process of a light ray turning back upon striking on a surface upon striking on a surface into the same medium upon striking on a surface into the same medium it's called reflection. They're falling on a surface, turning back, moving into the same medium is called reflection. Okay, same idea. Words may be different. Bouncing back also you can say. Whereas you can use the word, it is changing the direction, moving into the same medium. Right? So that we also can say. Right. Did you understand that? Right. Let's have a look. Laws of reflection. What are the laws of reflection now? What are the laws of reflection? Yes. Can I say the diagram is also given there? This diagram you have to label. What are the two laws? First law says that you have to learn these laws at the moment right now. You have to memorize. What are the two laws? Read them out. The incident ray, the reflected ray, and the normal at the point of incidence. Very easy. Okay, you take the words. You take the words to mind. Incident ray, reflected ray, and the normal on the point of incidence. What are the three? Incident ray, reflected ray, and the normal on the point of incidence lie on the same plane. Right? Second law says that angle of incidence is equal to angle of reflection. Or easier, incident angle is equal to reflected angle. I equals R. If the question asks you to write in terms, don't write I equals R. That should be secondary. You have to write the terms. And then you have to write the bracket I is equal to R. Okay? So learn them now. You have to memorize. MBA. So that is not between the normal and the incident ray. So that is not the incident angle. That's not the incident angle. That is the remaining of the whole 90-degree angle. Let's say if they are given this angle, you can find it by using a term max for that, I guess. Not for the type. Composite or something. Complementary angle. Complementary angle means for 90-degree and 90, both you are using it. For one is complementary, the other one is supplementary. Supplementary, right? Or supplementary. As I put it, supplementary, right? Supplementary is for 180. Complementary for 90. Am I correct? Yes. So let's say if they are giving this angle as somewhere around 60, then how much should be? It should be 30. It should be 30. Right? 90 minus 60. Okay. But you have to remember that is not the incident rate, it's incident angle. This is the incident angle. Yeah, if these two are equal, definitely this should be equal. Right? Let's say 30, then it should be 66 because this is 100. But this happens on one condition. Mirror should be, or the surface should be plain, flat. A regular reflection should be taken place. Let's say on a rough surface, it's a rough surface. The rough surfaces won't be giving regular reflection. They move here and there. When they are moving here and there, again, angles won't be. And basically, because of this rough or irregular reflection only, we can see diffuse reflection is we can see each other in every angle. Imagine if I'm not giving out diffuse reflection, only in one perspective you can see me. Understand it? Because light ray comes on, strikes on my surface, and it moves into the opposite me, equal angle. So through that angle only you can see the certain parts. Okay? But since we are irregular, diffuse reflection is carried out. Everywhere it is diffused throughout. So whatever, wherever you are, you can see. Okay? So all the things you can see because of diffuse reflection. Say about that. Right. So memorize the two laws there. Right. Can you tell me what are the two laws? Incident ray, reflected ray, and the normal at the point of incidence rely on the same thing. Repeat it. Incident ray, reflected ray, and the normal at the point of incidence rely on the same thing. Second one, incident angle is equal to reflected angle. Angle of incidence is equal to angle of reflection. I is equal to R. Clear? Right. So the next, it goes up with the diagram there. Previous name them. And here on the plane, it's BC, it should be B. Point of incidence should be B. Okay, not BC, B. Right? Look at this image. We're going to draw the diagram for a point object. So we are starting from the very basic part. Okay. Pointed object. How to draw a ray diagram for a pointed object? Pointed object. You can see the mirror given here. That's straight. That's right. No. Okay. And imagine it's straight. Right. I'll take the point here. This is the point of view. Okay, this is the point of view. So we're gonna find out where will be the image be. Now, very first thing is when I'm drawing the diagram, I have to make sure if I have taken the correct side. What it is. This is the mirror, right? So that should be the place where I have to keep the object. I can't be inside the mirror. I have to be front of the mirror. In front of the mirror. So front of the mirror, I have to take the point. Right? I took the point in front of the mirror. So front of the mirror, I have taken this point. From this point, I have to take minimum 2 rays. Whenever we are drawing the ray diagrams, minimum 2 rays we have to take. Taking 2 rays, I have to find out where will be the image. Where will be the image. So what I have to do is, I have to take 2 rays. One is there here, striking on the surface, and the other one is. These are the 2. And then we have to apply the reflection rules. What are the reflection rules? When a incident ray is striking on the surface, it will be reflecting, making an angle equal. Incident and reflected angle should be equal. So imaginary line from the equal angle it should be given. Equal angle should be given. Right? And then the other one also I'm going to take the same way. So can you see now? This is the incident ray. I'll take it as O A and O P. Same letters, no? ACR. OA is the first incident ray. OC second incident ray. OA reflects out as AB. OC reflects out as CB. Now, when I'm looking from here, I want to get a real image. There are 2 words. Learn the words now. Real image and virtual. Okay, these are some current students. They want to get the clear idea, but they learn like a parrot. But it won't be working. Real image, virtual image. Okay. Imagine now. I'm in front of the mirror. My image will be the inside. I'm the object. My image will be the inside. Can I take that image out? Can I? Can you take your image out when you are standing in front of the mirror? If it comes out, usually it comes out. You won't be looking at the mirror again. But right, those stories may be there. Will it be happening like? Is it true? Happening? Might be happening. There are some unknown, unseen worlds also. Man is not the only creature. There are many others that may be happening. If it is happening, don't try it the second time. Okay. Don't try again. Right? So you may think that no, say it's in rural areas, not only rural areas, wherever it may be, we can't predict. Okay, but we have to be more careful about the environment that we are in. Right, anyhow, so here, and you say I can't take out the image. That happens only in the movies and cartoons. The hand coming out, the person coming out, half of it. We can't take it out because it's not a real image. An image which cannot be screened out, which cannot be taken onto a screen, which cannot be projected onto a screen, cannot be. It's called virtual image. Let's see if I can take out the image. If I can take out the image, that is called real image. That is called real image. Is that clear? Clear? Real image, virtual image, is it clear? Real image can be projected out, virtual image cannot be. Right. Real, virtual. But how do we find it? Look at that. Reflection. Incident ray reflecting out, second incident ray reflecting out. Now let's say the reflected rays, not the incident. Reflected rays. There are 2 reflected rays, right? A, B, and C, D. If these 2 reflected rays are crossing out like this, somewhere, wherever if they are crossing out, If they are intersected, if they are joining together, then there would be a point where they are meeting up together, right? Something like this. Right? If they are crossing out like this, there would be a point where they are meeting. That is the point where the image would be formed, and that image would be real image. Why? Front of the mirror image is clear. Is it clear? Why? From the object the light is moving on, it comes out and it crossing out, so a real image. Such things never happen in paintings. In mirrors, real images are not. That means when I'm standing in front of the mirror, maybe the same light structure comes out. It can't. It may be happening in the unseen. Right? Okay. So it can't be happening in real. So no real images. Then what is virtual? Now, since it can be, you can see clearly they want to intersect. They never intersect. They go away. If you argue, no, so only for this diagram it might be. What if it is another diagram? Oh, if it is, it's only for a pointed object. What if it is a non-pointed object? Whatever the object you draw, this the same concept you apply. You could see they go away. They reflect. They won't be meeting, won't be intersect. So there is no real image. Then how do we find out the virtual? Now, somewhat I'm not getting the real. I have to be satisfied with what is there inside the image. How do I get it on? Now these 2 points are there. I'm going to drag. Right, I'm going to. Okay. So now I'm dragging these 2 lines. You can see now these 2 lines are meeting up a point, right? And it is meeting up on the mirror, on the line somewhere here. Right? This line is also imaginary. You can't see this line. Right? This is the point where the image is formed. But is it a real image? No, it's a virtual image. Why? Reflected rays, the backward we have dragged. Inside the mirror we have dragged, so it is green. But do we practically do that? Going to see. Yeah. As a radar, we are drawing. So this gives you virtual, you can't take it out. Maximum up to this point you can take. When you are moving close to the mirror, it comes to also. Okay? Right? So here, there are some points. What are the points? The points would be like object size would be equal to the image size. Object size would be equal to the image size. Right? Means imagine I'm standing in front of the mirror. My image would be given there. Will it be enlarged? Will it be diminished? Reduced down by size? Same image. Same image will be there. Object size is equal to image size. But I'm standing on the foot. Will it be standing on the head? It won't. Real life, it won't happen. So, upright image. Upright means straight away the same. If I'm standing on the foot, it will be on the foot. If I'm standing on the head, it will be also the same. Okay? So, upright. Upright. And is it a real image or a virtual image? Virtual image. So, virtual image, upright image, object size is equal to image size. And what about the distance? Object distance. I'm the object here. Between myself and the mirror, there's a gap. That is object distance. And between my image and the mirror, also there's a gap. That is the image distance. So this is the object distance. This is the image distance. These 2 would be also equal. How do you say equal? How can we prove that it's equal? Can we go inside with the tape and measure? And how do you? Imagine there's a mirror here. I'm standing up here. In between myself and the mirror, there are some objects. Right? All the objects I can see inside as it is. But beyond the levels, wherever they are, same way, it will be there inside the mirror. Same size, same place, everything same. That means I'm having this. But furthermore, let's say I'm walking, I'm standing on a tile surface or something. 2 tiles are there, let's see. The gap 2 tiles. 2 tiles means about 2 feet. So the same 2 feet would be there inside. Inside. So image distance is equal to. Is that clear? But only one difference will be there. What do you think? Only one difference will be there. What is it? I'm raising up the right hand. What is left hand? Yeah. That means I haven't seen the mirror. In front of the mirror, you are standing. Imagine you are touching like this. What do you do? In front of the mirror, doing like this, like that. So when you are touching the right ear, you could be touching the left ear. Yeah. sides will be changed. This is called lateral extension. Only this is the change. All others are same. If it is not doing the same, let's say that's the problem. Right here, it's also stuck up with the right here. Then you have to think about it. You have to clear about it. Whatever the object you take, point or non-point or whatever, say these are the properties of plane. Have a look what to do. Yeah. So they are parallel. They won't be parallel as well. Why? These two are not parallel, right? So can I say what's the question here? What about BC, AB and CD? Will they be parallel? They won't be parallel. Why they are not parallel? Okay, it's because of OA and OC are not parallel. If they are not being incident parallel, how come the reflector also getting parallel? They will do it. Because they have to make the equal angles, right? Giving the same equal. Okay, now you may think that equal angle should be parallel. Equal means these two are not equal to the other two, right? Within themselves, 30-30 equal. But is that the same 30 given? It cannot be right. Practically, it cannot be. Why? On this point, if it is 30, somewhere else it should be more or less than 30. So it's away from that point, definitely more than 30. And what is the angle given here should be the reflected angle. Okay. Okay. Yeah. Right. So accordingly, it's clear now. Now the properties given, all images formed by plane mirrors are virtual. These are important in MCQs. They ask you what is the correct or wrong statement. Virtual images, object distance is equal to image distance, object size is equal to image size, images are lateral inverted. Lateral inversion means they are clearly changing the size. Did you understand that? Right. Now, such a diagram is asked for you to go in the diagram, go in the question. How do you? As I have drawn a nice diagram. Nice. Going here and there. That happens when you are drawing. So there should be a method. This is the correct. But because I didn't use a rule. I didn't use a rule. So if I'm using the ruler, I have to straight away take this like this. But there is a point which may be gone wrong. If I'm following the correct method. What is it? Now I'm drawing this first line, and then I'm dragging this line. Thereafter, when I'm dragging this behind me, sometimes that the point may be coming somewhere here or somewhere there. Which may be, when you compare with this gap, less than that gap or more than that. It may happen. That means our diagram is wrong. Why? Theory says that, law says that object distance should be equal to image distance. You understand? Then how do I do? How do I do? The short method means. What is the short method? It is not must to do. No, imaginary lines are here. That one. This one. Now, after the correct method, we have to draw, and then only we can get the image. Okay. Now, my point is, if you're gonna take it somewhat, okay, sometimes it may be less. It may be catching up here, or it may be going here. Then it won't be equal to the object distance. Understand that? Something like this. Sometimes it may be coming up here, but the object distance is here. So it is less than. Sometimes it may go like this, and it's coming down, up and down also it may be changed. So how do I make it 100% perfect? Short method. So distance from that O to F and then F. Exactly. Structure, that is what initially I did. Okay. So what I do first, I take the mirror. I took the mirror. Short method. You won't be getting a problem here. Because of short method, will they be reducing mark? They don't know what is the method. We have to tell them. Just the answer sheet. So, you measure this. Same, yeah, you take the other side also. Okay. You have to take both sides same. Both sides have to take the same. Let's say you took 5 centimeters. First, you measure 5 centimeters. This 5 centimeters, let's say. Exactly measure 5 centimeters. Right? That's the first. Second step, take 2 lines. Mostly they won't be giving the angle. Take this angle, that angle they want. Okay, any angle you can take. But don't drag it longer down. Then the diagonal becomes long. So take it short. Exactly on the point. I can't start somewhere else. If this is the point, both the points should be from the same. Cannot be up and down. Design structure. I take from here. Stop. Exactly. To raise interpret. Correct method is I have to reflect it. What is the short method? Starting. Definitely, I know that it won't be real image. So up to this, I'm taking a virtual line, imaginary line. Okay. And again here, imaginary line, like these two lines. And then, what is the line? Here, straight and straight. So you have to keep the ruler straight. And again, straight here. Okay. Then what happens? Then your image diagram won't be mistaken. Why? You are getting the same object distance equal to. Did you understand? Short method is clear about that? I want you to do that. On your item book. Now, put the topic as it is given. Ray diagram of a pointed object, and please make sure your pencil is averagely sharp. Not tiny sharp, not sharpened, not unsharpened as well. Tiny sharp means once you tip it will be broken. Or else it tears off the pages. Or what you do is slowly you will be doing it. Right, it's very sharpened. It should be used one. And it should not be a flat one as well. Right? Flat one will be giving double lines. Double lines are not acceptable. And please don't show your artistic skills. Like this. Now, don't show that artistic skills on this radar. This is not art. Okay. One line knockout you have to finish. Right? So straight line you take, and the ruler should be very perfect because there cannot be wavy patterns like in this way. Clear rule. And listen. The other thing. Now let's say this is the point you are going to start. Design structure. If you are following this part, initially it would be harder. 1, 2, 3 diagonals you are drawing, the rest of the parts will be more easy. And you won't be mistaken. Small dot slightly, on the paper, if you are going to keep a small pressure, it will compress. It will be depressed down. A small hole will be there down. But make sure not to tear off the page. Alright, that's why I said not to be very sharp. Slight. And if you are giving the ruler here, and let's say this is the point you want to end up, keep a point here. Now keep the ruler and measure if the dots are aligned with the ruler's line. When you are keeping the ruler like this, you have already kept 2 points right, 2 dots right. Measure if the dots are being exactly aligned with the ruler's surface, both the lines. Until then, you have to adjust and then roll. There you start, there you end, exactly you can finish up. Why? When you start, you can feel the depression. When you end up, also you can feel it goes down. Pencil goes down slightly. You understand that? Then your diagram is done. But it should be a clear line surface. It should not be flat line. I mean, it should not be a double line. Okay. And we have to start up exactly that point all the way to. Don't go beyond this level. That's wrong. Or above the level also, that's wrong. Exactly on the same. And this line should be 90 degrees. That's it. First diagram. You are going to go now. Take the instructions and please go. You will also draw a diagram. Diagram is shared with you, but use the short method to do it. So onliners, once you are done with the diagram, you have to show me the diagram. You have to take your cam closer to the diagram and you have to show me the diagram. Is that clear? Take your cam, you have to place your camera closer to the diagram and please show it. So complete your diagram. So your diagrams are very easy to score marks. But why you are mistaken? Because of the instructions I said you are not following. You are just going. Because the theories are very easy. So you are going to apply the theories just without any regulations, you are marking. The virtual lines shall not be marked on a straight line, complete straight. It should be dotted lines. So this also has to be the same. Because actually these lines are not appearing on the ray. Only the rays that we are using and the mirror should be on complete continuous lines. Are we done? Erase. Should not be one thing as well. That will not. Line goes exactly true. So I said to keep it. Done. And have you good? Don't take the point bit down. Just a drop. Okay. Because of sometimes when we are making the dot denser, it deviates from the exact point where it is meeting. So that should happen for you. Somewhere it is pointed up here, but you have taken it to the left side, to the right side. Correct. And here too, there is a small mistake, but somewhat there is a. We started from here, but the line is above. This is the point, right? We started the way from here. Correct. Correct. Okay. And we have tried to adjust it. Correct. It's also not meeting here. This is the line. This is the line. Correct. Correct mistakes because of with that mistake when you're going now, you may think that. So is it that much finely observed this? Only one ray diagram would be given. Usually the ray diagrams for the rays, for the shape, you will get marks. They won't just give the marks. Yeah. Some questions are there where they will give you to, they'll ask you to find out. Okay. Not here, not this one. Later we have to learn about convex, concave, mirrors and lenses ray diagrams. On those diagrams, what they do is they will give you the part. Incident part they will give you. And they will ask you to complete on the paper itself either the reflection or the refraction. The mirror or lens, depending on that, they will ask to complete. Now there will be an image form, right? Questions marking scheme consists of give marks if the image size is. Let's say the exact size is 1.42. Exact size is 1.4. 1.4. Okay. Correct size should be 1.4. They will give you the answer here. Give marks if the image size is 1.38 to 1.4. 4 points, 4 decimal points they will be giving as optional score. Okay. So your answer should be, your diagram should be, I mean the image size should be between that 1.3 to 1.4. They will mention. So for those types of questions. Is it clear? So from the beginning you have to practice. That's not so hard. Initial now starting you may think very hard. But with these steps when you are going on, the rest of the diagrams will be very easy because mostly these diagrams they want us. These are the basics. Okay, these are the basics. All right, we'll have a look over the online as also. Correct the diagram, please. Correct. Draw it down again. Don't erase it. Draw it again. Let me see. Yes. Show me the diagram. Yeah, turn on the video. Show me the diagram, please. Right. Yeah. Better farmer, keep the book. Just keep it quiet. Ahmad, the reflected ray you haven't taken it yet. Can I see here? Right? I'm pointing out. Let's say it.
Yes, yes, sir. Okay.
I'm pointing out.
Okay, sir.
Everyone can see the diagram, right? So you see here, this is okay. Second ray is also okay. But you have taken only the imaginary lines there. You haven't taken the reflected rays. Can you see? Here the reflected rays should be there. Can you see? Those reflected rays you have to take.
Oh.
You understand?
Okay. Yes.
Yes. Okay. Fine. Next, let me ask. Afa? Yes. Afa. For the diagram. Turn your cam towards the diagram. Is it? Okay, fine. All right. Okay, let it be. Aransha? Send a picture. Fine. Send a picture. Aransha, yours.
Okay, sir. Okay, sir.
This Aransha, right? Wait for a while. Aransha's. Okay. Okay, good. And this arrowhead is not needed here. So between MO and MI, Aransha, take off the arrowheads there. No need of that arrowheads, okay? Actually, on the tube, what is given is not the arrowhead,
Yes.
that's the equal mark. That usually they are showing the diagrams, equal lines, equal sides, that the symbol is given there, okay? Yeah, that's good. Next,
Okay.
Akila.
Okay, sir. Okay, sir.
Akila.
Hirap pa ping pakam dakrila.
Akila is there? Okay, I'll check it. Yes. Akila, your diagram, please. Might be processing. Until then, Razima. Razima, your diagram, please. Yes. Akila and Razima, are they right? The diagram, please. Until then, Shahir Ahmed. Shahir, yes, your diagram, please. Turn down. Then, yeah, Akila, take a photo and send me now. Akila, take a photo and send me. And this is Fahuma, right?
Sir, I have
Okay, Fahuma.
right.
Yeah, Fahuma, that's correct. That's correct. Yeah.
Okay.
Check out with the points as well, okay? Shahir, how about yours? And Sheikha? Sheikha, yes. So has something. Let's have a look on. So I'll share the image and I'll speak to you, okay? Okay, chart make also. Okay, fine. Okay, Akila. Later you can say. So, shape image has. This is Afaz, right? Afaz. Afaz, there's a small mistake. The diagram goes correct, but look at this point. This point is wrong. This point is wrong. Can you see? That is a wrong point. It's because of okay, they are not meeting up, they are not pointing together. So there's a gap. Here it is one, and the other point is there here, right? So that is a mistake here. So correct it, draw the diagram again where both the rays should be meeting up together. Rays should be meeting up together on the line. Okay. Fine. And go to the next one. Yes. Okay, good. Have you taken that 5 centimeters gap correctly? And there's a small mistake. That is, can you see this point? This is the point where you have started the image, the drawing, and this is the line on the surface. Can you see? So they are not meeting up together. So you have to exactly take from this point. Is it clear? Exactly from this point only, you have to draw both the ray diagrams. Okay. That's a mistake. That's the only mistake. Others are okay, but seems to be your pencil is also very too thick. Okay. Better slightly sharper. Otherwise, the diagram consists of 2 layers. Okay. Fine. Anyone else help with the image? Who's that? Razima. Razima, arrowheads are missing. Take the arrowheads on, okay? Mark the arrowheads, and virtual line should be imaginary, so that should be on dotted lines, okay? These 2 lines are there, these areas. So these areas should be imaginary lines, right? So these areas should be imaginary lines, dotted lines you have to take on. Others are fine. Okay, so far everyone sent, right? Yeah. So let's take a small note on your writing book. Take your writing book. Types of mirrors. So the mistakes I have said you now, please correct them. Okay. Yeah, Akila, you can send me the image later. types of mirrors. There are two types of mirrors. Two types of mirrors. What are the two types of mirrors? We divide them into two as plane mirrors and curved mirrors. Curved mirrors, plane mirrors. Plane mirrors, let's say this is the plane surface. One side is the plane mirror, the other side is shaded. So where should be the light ray coming from? Light ray should be coming from the plane side. This is the point where the light ray comes on. Right? And reflection arc should be taken to the same side. Cannot be flipped. So as far as the image is inside, that is virtual. If it comes out real, but it doesn't take place in plane mirrors. Curved mirrors we are dividing into two. Can you remember the names? Convex and concave. Convex, outside curve. Mirror is outside. Mirror is outside. Concave, inside curve. Mirror is inside. Outside is shaded. Outside is shaded. Okay. Something like this. Imagine you are taking your hand. You are keeping the hand like this. Outer surface is convex. Inner surface is concave. Outer surface is convex. Inner surface is concave. Outer surface is convex. Inner surface is concave. So convex, this is the direction where the light falls. Concave, this is the direction where the light falls. Okay. And since they are curved, the images go different. Different types of images are being given. So about them, we have to separate them. Okay. Is it clear about this? Draw it. I'm writing. Right? Fine. So we are done with that lesson we are supposed to learn today, and we have to speak about these curved mirrors next week. Please refer and come. Okay, what are the basic fundamentals? Some small principles are given of the ray diagram. what type of ray it is, what is the name they are giving, where it is starting, where it is ending, if it is convergent or divergent, along with these two. So refer and come and revise with what we have learned today. Okay. So next week, inshallah, we'll be taking up with convex and concave mirrors. Okay, no? Next week, yeah, we are having classes. Okay. Festivals falls on somewhere maybe Friday or Saturday, right? And maybe it's the further night as well, the day before the class, and then Tuesday evening, late evening. So anyhow, you have time until 4 o'clock. Usually you're sleeping, no? Like like an hour, you're doing all those works the day before, and the next day without liquor until Asar you are sleeping. Okay. So still after Asar you can come to the class. Okay, no? Fine. So that's it for today. And guys, tomorrow we are having an iftar. Okay, we are having a seminar also. So those who want to join the seminar can take the seminars too. It will be conducted both online and physical. Okay, but the main theory tomorrow is the iftar. So this is the very first time we are going to organize an iftar from the class. Separately, iftar is being done throughout this month in Saturday class. I'm having iftar. It's class crossing time. So one day I did, the second day the boys did, the third day the girls did. So like that it goes on. So that happens usually in the regular class times. So this is separately as from myself, I'm going to do. So I have invited everyone. So I think not personally, privately taken on. So group I have sent it. So please join it. That will be contact at syntax, which people also can join. Okay. So you can come there about 5:45, around 5:45. You can be there. Okay. If you are coming, please fill up the form. Okay. I expect you people would come. Okay. Onliners, if you are close by, some of them are closer, right? You can also join. Okay. Say then, good evening. So, Akila, send me the email, okay?